I am Lavanya, Assistant Professor of Physics, A.D.M. College for Women, Nagapattinam. Today I am going to discuss about what is liquid interface, surface tension, interfacial surface tension, and what are the factors affecting the interfacial surface tension and so on. Okay. First of all, what is interface? Interface is the boundary between two or more phases exist together. So there is another term is called surface. What is surface? Surface is normally used to denote interface when one of the phase is gas. Between of two phases, there is a interface. What is interface? The bounding that exists in the between two phases. That is, one of the phase is gas. That interface is called the surface. These are the different types of interface depending on the gas. These are the different types of interfacial depending on the in gas phase, when there will be no interfacial tension, and so interfacial possible between gas phase. Okay. Next, there will be interfacial tension. It is represented by gamma LL. It will be the liquid surface and example of this body of water exposed to atmosphere. Next, the liquid is designated gamma LL liquid. In liquid interface, result is emulsion. That emulsion can be peanut oil in water, or they are combined to different liquids that are immersible in each other. If the liquids, only there will be a interface. If the liquids are completely miscible, then there will be no interface between them. So, if liquid solid interface, the interfacial tension represented by gamma LS. So, type is liquid. Which type of the interface in liquid solid is liquid solid interface. That is the type of the liquid and solid interface. So, and examples of interface is suspension. So, next one is solid interface. What is mean by that? Solid interface, interfacial tension represented by gamma LS, and type is solid interface. Example of interface is powder particle in contact. For example, when two different powders are in contact with each other and two different powders are mixed will be contact with each other, and this is the example of solid interface. This figure shows this. If this is a solid and in this phase is gas, okay, this is the solid and this phase is gas. This interface between the solid and gas is called the solid gas interface. This figure represents another example of examples. This figure also represents there is you taken as a beaker, and in this certain solid in present that beaker, this is the solid. Okay. So in this there is the liquid and phase that exists that between the solid and liquid is known as the solid liquid interface. And an example of solid liquid interface is what? That is the suspension. Okay. So, and if we consider another state, that is the liquid interface, it is a part that there is another liquid is also in that part, and this is any oil. Suppose oleic acid, you have to take in the oleic acid. Suppose the interface or that boundary exists between the two liquid will be known as interface. This interface is called the liquid interface, and the example of the liquid interface is the finally is emulsion. Now we are going to see what is surface tension. So surface tension is defined as the force in dynes acting on the surface of the liquid at right angles at any line of length strength, that is 1 centimeter. Okay. Surface tension is the property of the surface of a liquid that allows it to resist an external force. So this is the property because of the liquid lies to attain a minimum surface area. That is the concept. The lies to attain a minimum surface area. A liquid molecule tries to maintain a minimum surface area and will be spherical in shape. This is the phenomena. Because of its fall in water, droplets will form spherical in shape due to the surface tension. So the droplets of mercury also spherical in shape because of the surface tension. So the mercury will form the spherical shape, and the surface tension phenomena is revealed in floating of some objects on the surface of water, even though there are denser than water, in the ability of some insects for water striders to run on the water surface. So what is surface tension? Surface tension is the property which is the phenomena that is defined as the force in dynes acting on the surface of the liquid at right angles at any line of length of strength, that is 1 centimeter. So, and this is the represented by letter is gamma. Next is in the surface tension in a liquid, molecular experience greater attraction from the neighboring molecule. Say we have an example. In the pot there is a molecule, we consider it molecule B, and the molecule on the surface consider is S. Okay, so the molecule B, there will be certain molecular forces in the molecule experiencing greater attraction from the neighboring molecule. So the such intermolecular attraction between the like molecules, same molecules, are called the cohesive force, while attractions between unlike forces are called adhesive forces. So this is the liquid at this second molecule, attraction in the neighboring molecule of B, that is S is attraction to the B molecules, or B molecules are same. That attractions, the attraction force between the molecules or between the like molecules, between attractions of between the molecules means B and S, that is the same molecules, between the like molecules is called the cohesive force or cohesive. Okay, so due to these cohesive force, is this molecule will be trying to attain a minimum surface area. At this surface it will face some forces from the neighboring molecules, but no molecules above the interface. There is less adhesive force, less attraction between the unlike forces. There is less adhesive forces, less attraction force between the adhesive unlike molecules, that is the adhesive forces. So this is the meniscus will lies to tend to pull downward with the help of the cohesive force. So there is two type of forces. One is cohesive force, another one is second one is adhesive force. So the force that exists between the like molecules is called, already I told, that is the cohesive force. And the force exists between the unlike molecules is also called exactly adhesive forces. So and due to this cohesive force, this molecule will try to combine a minimum, will try to attain a minimum surface area. So this cohesive force among the liquid molecules are responsible for phenomena of surface tension. By measuring the strength of the cohesive force, it will measure the magnitude of surface tension. In the bulk of the liquid, each molecule is pulled equally in every direction by neighboring liquids molecules or by cohesive force. Why cohesive force? Because same type of the molecule is present inside around this. So this is pulled equally every direction by the neighboring molecules or neighboring liquid molecules. That result in a net force is 0. So because of this force acting in every direction, so there is another molecule resting on the surface. Suppose this is the S. In this case, molecule at the surface do not have molecule all side of them. No molecule that above enter the line. No molecule that above enter the line. So the molecule at the surface do not have other molecule on all sides of them, and therefore are pulled inwards. So this creates some internal pressure and the force of liquid surface to contract to the minimal surface area, to attain the minimum surface area. So this is the phenomena due to which the falling water droplets of the rain will acquire a minimum surface area because of this case. So the molecule receive phases that attraction from the neighboring liquid molecules, and due to which some internal pressure will create and this internal pressure forces the liquid surface is to contract to the minimal surface area, and when tried to contract the minimum surface area will attain a spherical nature, that is the spherical shape. Okay, so surface tension is represented, the letter is gamma. Is the force per unit length must be applied a parallel to the surface so as to counterbalance the inward pull. So the CS, that is the CGS system of surface tension is dyne per centimeter. In MKS system of surface tension is newtons per meter. Next phenomena is interfacial tension. What is interfacial tension? Yes, exactly. In the force per unit length existing at the interface between two immersible of liquid phases, the unit interface tension is the same as the surface tension. Okay, these are the same unit, like the interfacial tension and the surface tension is same unit. Okay, so the CGS unit of interfacial surface tension is dyne per centimeter and the MKS system is Newton per meter. So interfacial tensions are less than the surface tensions. It is very important. The interfacial tension is a less value than the surface tension because the adhesive forces between the two liquid phases forming the interface are greater than the water, a liquid and a gas phase exist together. So surface tension is, the phenomena of surface tension is responsible for the following process. For example, formation of spherical globulus in emulsions, formation of nearly spherical shape of falling water droplets, formation of spherical shape of mercury particles on flat surface, rise of liquid in capillary tube, and the phenomena, these are the phenomena of the surface tension. We have seen this, the beaker, the water, when water is placed in that beaker, this it will attain a lower meniscus. Okay, this will attain a lower meniscus there. This lower meniscus is due to the surface tension. Why? Because the molecules that are present in the surface will facing inward pull, and due to inward pull in this meniscus will be lowered down and it will attain a semi-spherical shape. So the formation of semi-spherical surface have lower meniscus when water is filled with in a glass tube. Not at all glass tube or in a beaker or in a conical flask. The water will try to attain a hemispherical surface that is lower meniscus than is filled to the glass. Okay. So next, factors affecting surface and interfacial tension. So there are three factors which affects the surface and interfacial tensions. So what are the three factors? Like internal factors, external factors and effect of temperature. In internal factors consists of intermolecular attraction. There are certain interreactions, molecular attractions that molecules feels because of their neighboring molecule. So this intermolecular attraction affects the surface tension as well as the interfacial tension, and the magnitude of intermolecular attraction shows a magnitude of surface tension. So by measuring the surface tension, we can easily calculate the magnitude of intermolecular attraction. Next is external factors. So external factors consists of electrolytes. It works by addition of electrolytes. There will be an impact on the surface tension and interfacial surface tension. It can be increased. And if for adding certain surfactant and some reactions, for example, in twins and spans, these surfactant will reduce the interfacial tensions between two phases and will help soluble gas station will help in visibility. So there are certain external factor like electrolytes, surfactant, there will be affect the surface tension and interfacial surface tension. Okay, that is the very important. The electrolyte and the surfactant will affect the surface tension and interfacial surface tension. So the last factors that affect the surface tension and interfacial surface tension is that is the effect of temperature. So with the help of temperature is increases, the temperature, then kinetic energy of the molecule will increase. If the kinetic energy of the molecule will increase, then here will be the increase in the surface tension. That means the increase the temperature, increasing the kinetic energy of the molecules will increase, then near will be the decrease in the surface tension. That is the concept. Okay, and in this reason of this critical temperature, that is the reason for the why decreasing the surface tension when raising the temperature, because the reason of this is critical temperature. So these are the surface tension of the liquid becomes 0. Okay, so I hope all you understand, all of you, I hope you all understand what is interface, what is surface tension, what is interfacial surface tension, and what are the factors affecting the interfacial surface tension. Okay, good. Thank you.